Good evening, everybody out there in YouTube land. Um, it's me again, Mr. DOS Man. Um, my voice is starting to come back. Just, unfortunate that I lost it for the first video, but whatever. Um, so in the first video, we went over kind of how to get our thing set up so we can actually do some basic development. Now, let's do some graphics. That's kind of the most important thing people think of when they think of games. Um, while you can do a lot of nifty text mode stuff, graphics is kind of where it's at. So I prefer to use graphics mode 13H or OX13, depending on how you like to talk about your hexadecimal values. Um, and the reason I prefer this graphics mode is it's 320 by 200, but it's got a 256 bit or 256 color palette. That means each pixel is exactly 1 byte. That makes doing the math for plotting pixels, copying memory and stuff. It's all very, very simple. So how much memory does does the frame buffer take up? If we do some quick multiplication, 320 times 200, that's 64,000 bytes. So that seems like an awful lot. Like if you were doing a game and you were really only intending on using the low memory, the first 640K, that's about 10% of your available space is going to be used by the frame buffer. It's kind of a lot. But we're using pseudo-SD PMI, so we're assuming we've got the full range of memory available to us. So if you're going to be running this, if you're using DOSBox as your development environment, you've got more than enough RAM to play with. I think by default it ships with using up to 16 megs of RAM. Nothing we're writing is going to come even close to that. So yeah, it's huge, but it's not an unreasonably large amount either. Especially once you get to using a double buffer, it can really add up. But since I don't actually have any real authentic DOS hardware to test this on, kind of hoping we'll see about that next year. I'm I'm fine, kind of pushing up against the edges of DOSBox as kind of being the target environment for these games and whatever. Uh, it's getting kind of hard to find original DOS hardware. Oh, excuse me. Like those Sound Blaster cards and MIDI cards and just even VGA cards, the CPUs, the RAM. It's all very expensive now. So if what we write only works in DOSBox, that's unfortunate, but that's also how most people are going to be able to play and enjoy these games. So, alright, how do we make this work? What do we need to do in order to make something usable? Well, so the interesting thing about programming for DOS is you're actually programming directly against the CPU, the BIOS, and the operating systems, and you communicate back and forth using a feature called an interrupt. So, what does it mean when you interrupt something? That I'm not really sure why they're called that, but I'm pretty sure interrupt 10 is the video interrupt. There's a whole page of them. I'll find it and post it in the links. Some are reserved for the CPU itself. Some are reserved for the operating system. I think like all of 21H is actually how you program against DOS for stuff that's not in the standard library. Even then, I'm pretty sure in the back end of the compiler or whatever, it's just translating those calls to int21h for you. So yeah, so some are for the CPU, some are for the BIOS, and some are for the operating system. So if you wanted to write your own enhanced version of DOS, like say you wanted to do like setting up a TCP thing, you could probably do that with interrupts. I don't know, I'm just kind of speculating here. I'm really concerned about building single player games. It's totally possible to do multiplayer games, but single player is kind of what the focus is on for this series of videos, anyways. So I'm gonna just kind of move along and show you how to make that interrupt call. Before I just sit here wasting so much more time. So we're gonna need DOS.h. There is no DOS configuration, so we'll need to I'm not going to worry about that since it's all living in there. Just know that we need a DOS.h. And let's just ignore that error for now. So did I actually find this, or is it just substituting in here? Okay, it's just pretending it's knowing what's going on. Alright, so we feed int 86, which is the name of the function from DOS.h. We feed that registers. And that's all the communications handled when doing interrupts, is you have registers in and registers out. If we were to actually inspect reg, let's see if I can find the source online for it. Right. So this is available on includes, this is DOS.h. So we have some dword reg. So that's kind of your long registers. EBX or EAX, EBX, ECX, DCX, and some other things. Some more registers, word registers. And we're interested in the byte registers. So if we go down here, we should find okay, so here's int 86. So what we pass to it is the interrupt vector, which is the number of the interrupt. Union reg in, union reg out, and that can be the same set of registers. So if we go back up here, here we go. So, and see what a union does is it basically all of these things take up the same amount of memory. So whichever of these structs is largest, that's how much space this structure is going to take up. So it can take up to the largest amount of bytes. So we are interested in the H registers because, you know, these are the interrupt vector we're calling was originally for the 8086 processor. So it's 86. We're going to call interrupt 10. Sorry, that's hexadecimal 10, so it's actually interrupt 17, I believe. It's 10. Oh, with let's see. It's dark. I can't. Here we go. That's what happens when you try and make videos like way after you've expended all your mental energy for the day. All right, so now we need to pack out this register. So we're going to use the byte registers. So that's a high and a low. I remember we have to explicitly set this one to 0, but I'm not entirely sure why. Let's go ahead and run this, and what it should look like is it should look like it's been set to 320 by 200 instead of the normal text mode. Oh, is Docker not open? Whoops. Poor planning out on my part. I should have started Docker before I started making the video. That's okay. It starts it pretty quick. And Docker's running. It's great that I can kind of pause the video while it's doing stuff. Otherwise I could get pretty awkward. Okay, let's give it another shot. Python.build. Alright, so it built. So let's run this. Let's go to drive D. Run hello. What's up, world? If you notice that that's a much different font than we've seen before. So it's much fatter, much thicker, a little bit chunkier. So yeah, so yay, we changed the graphics mode. So what do we do after we change the graphics mode? Well, let's put it back when we're done. Doesn't really. That's just being nice. Okay, so AHL. I think we want to go back to mode 3, which is the default. Which is the default text mode. And so it changed it, and that causes a clear screen, so we don't see what's up world. But now, I want to draw something pretty on the screen. So let me see if I can remember how to do random numbers in MS-DOS. I don't, so I'm gonna have to Google this real quick. So random will generate random numbers. X equals rand 320. So I mean it has to be between 0 and 320. Y equals rand 200. Okay, so we have our random things. Now we need to draw it on the screen. So if you're used to using SDL or some other C++ library, you think, okay, well, we need a surface or something. With MS-DOS, you actually can point directly to where video memory begins. Alright, so inside char void, and then we can point it right at so if you remember from high school algebra, y equals mx plus b, you can kind of rearrange that. So if we go VRAM y times 20 plus x equals c. So, just as a note, unsigned char is shorthand for, well, it's longhand for a byte, which isn't defined. So if all goes well, this should infinitely just draw fresh pixels on a 320 by 200 screen. Needs stdlib.h. What was I thinking? Oh well. That's the really nice thing about doing with Docker is you get the standard output of the container back to your terminal, so you can see where things go wrong. If you had to compile it inside DOSBox, that could get a little messy sometimes. So I mean, like this, I can copy and paste and Google it, whatever. It makes life so much easier. You cannot copy and paste text inside and outside of DOSBox. Alright, so at least it built. And we have a seg fault. That's no good. If I knew how to debug those, I'd tell you what I'd have to do. But instead, I'm just going to compare it to some code I know that works. Right. So there's a DJGPP-ism, unfortunately, that we have to deal with. I think this should work, because it's not actually at that address, because it uses CWS DPMI. Address space gets rearranged a little bit, the best I can tell. So we need to add this offset. So if we Google it and look it up, I believe it's just a macro for so there's some long reading about it. I don't know why we have to worry about it, but it's you're using DJGPP instead of a native DOS compiler, and you're using CWS DPMI, you have to do this. So let's try it again. Okay, so I'm missing it in the header. I really wish I could shake this cold. I don't sound like this normally. Alright, let's try that again. Yes, so it definitely has something to do with the near pointer. You know, how it talks to things below at 640K address space. Alright, so we're able to build it. Let's run. Alright, look at all those pretty pixels. Seizure warning, I guess. I don't know, it's not flashing so much, it's just drawing really fast. So, yeah, that's drawing pixels. So say you want a back buffer so that you can sync it with VSync. Well, that's totally doable. But I think I'm going to talk about that in another video when I get my voice back some more. We'll talk about that, having a back buffer and sprites and manipulating the palette. But I just really wanted to show off kind of getting off the ground, doing graphics things. So, yeah, if this formula is confusing, we're basically taking a 2D array and we're using a one-dimensional array address space to address using 2 coordinates. So, that's all there is to it. Thanks for watching, and well, I hope my voice hasn't been too much of a turn off from watching future videos. I'm having a blast making these, so I'm going to keep making them. If you like them, keep watching them, share them. I don't care, whatever. Have a good night.